Hello everyone, my name is Teja. Today I was here to explain about another topic from probability and statistics topic, and the topic name is Karl Pearson's coefficient of correlation. Before getting to know about this method, let's see what is coefficient of correlation. A measure of intensity or degree of linear relation between two variables is called as coefficient of correlation. It means that the degree of linear relation between any two variables is called as coefficient of correlation. And one of the famous mathematician discovered a method to find the coefficient of correlation, and his name is Karl Pearson, and the method name is Karl Pearson's coefficient of correlation, and it is defined as linear correlation coefficient that falls in value range -1 to +1, which means that the value must be -1 and +1, and shows that -1 say, is as strong negative correlation, and while +1 shows that it is a strong positive correlation, and it is indicated with the letter R. As we are taking or finding the coefficient between two variables, we're taking with the values as x and y. So it is also referred as x of r of x comma y, or r of xy, or r. As the value of r had different formulas to find, one of it r r is equal to covariance of x comma y by sigma of x into sigma of y, where x and y are values that of two variables. And using this formula, we have different three different formulas to find the value of r, and the formula is sigma summation xi minus x bar into yi minus y bar by n into root of sigma, sorry, summation xi minus x bar whole square by n into n into root of summation yi minus y bar whole square by n, where xi is the xi and y are the values of x and y at a particular point, and x bar and y bar are the mean of x and y values, and n is the number of values of x and y's. Using this formula, we derive a formula based on the requirement. The first one is r is equal to summation capital X into capital Y by root of summation x square into root of summation capital Y square, where capital X is equal to xi minus x bar and capital Y is equal to y minus y bar. As well know that xi is the value of x at a particular point, and x bar is the mean value of x, and y is the value at a particular point, and y bar is the value of mean of y. Here, capital X square summation capital X square means I have to find the value of x and y using these two formulas, and then we find the value of x square and y square, and then we add the values. And the second formula is summation x into y minus summation x into summation y by root of n into summation x square minus summation x whole square into root of n into summation y square minus summation y whole square. It shows that x and y are hard to find the values of x into y and its summation, and values of x and its summation, and value of y and its summation. And here we have to find the value of x square from the value of x, and find its summation. And here, and similarly, we have to find the value of y square and then its summation. And here, this both I have to find the value summation of x, and then I have to square it, and summation of y, and we have to square it here also. Similarly, as like this, I have another third formula using step deviation method, and it is similar to that of second formula, as r is equal to summation dx into dy minus summation dx summation dy by root of n into summation dx square minus summation dx whole square into root of n into summation dy square minus summation dy whole square. Here also similar that I have to find the value of dx and dy, as dx is equal to x minus y divided by h, and y minus b divided by h, where h is the value or n value of number of values of x and y. Here we have to find the value of dx and dy, product of dx and dy, and then we have to find its summation. And here we have to find the value of dx and its summation, and dy and its summation. And here we have to find the value of dx square and its summation. Here also similar to that of dxy dy square as dy square and its summation. And here we have to find the value of dx and its summation, and then we have to square it. Here also we have to find the value of dy and its summation, and we have to find its square. Using these formulas, using these three formulas, we can find the coefficient of correlation from the Karl-Pearson's method. Let's see an example. Here I'm taking calculate the, here I'm taking the problem as calculate the Karl-Pearson's coefficient of correlation for the following data. As these are the x values and these are y values I'm taking. As I'm using step deviation method, I have to find the value of dx and dy as I am using this formula. So to find the value of dx and dy, we have some values required for it. As xi is the values, these values, and y is this values, and we have to find xa bar. Yeah, the xa bar is the assumed mean of x bar, x, and y bar is the assumed mean of y. So we have to find the summation x, as x bar is equal to summation x by n. I have to find the value of summation x n by n as these are 10 values, so I'm taking n value as 10. Using this, I find x bar is equal to 35.6. As x bar of a is the assumed mean, I have I have to round it as 35. And similarly for y also, I have to find the summation of y and it by n, and n is 10. 313 by 10 is equal to 31.3 is the y bar value. So to find the value of y bar of a, I will round it as to 31. Make sure that these two values are in the x and y values, as y bar of a is 31 is present here, and x bar of a is 35 is present here. So let's calculate the value. Dx is equal to di x in xi minus xa bar. Sorry, I taken here as it has 36. Make sure it is 36 that. And 36 minus 28 is minus 8. 28 minus 36 is minus 8. 41 minus 36 is 5. 40 minus 36 is 4. 38 minus 36 is 2. 35 minus 36 is 1, minus 1. 33 minus 36 is minus 3. 34 minus 36 is 4. 32 minus 36 is minus 4. 36 minus 36 is 0. And 33 minus 36 is minus 3. Similarly, for y values, as I'm taking is it has 31. 23 minus 31 is minus 8. 34 minus 31 has 3. 33 minus 31 2. 34 minus 31 3. 30 minus 31 minus 1. 26 minus 31 minus 5. 28 minus 31 minus 3. 31 minus 31 0. 36 minus 31 5. 38 minus 31 7. So I have the values dx, y, dy, dx, dy. So I need to find the summation of dx and summation of dy. As we know that the formula, I have to find dx and dy. And at denominator, we have to find value of dx square and dy square also. So I'm finding the values of dx square here and dy square here. And then if you see the formula, we have to find the value of dx into dy value also, and its summation. So here I find the values of dx into dy also, and make sure that you have to find the summations of all these values, which will be required for us later. See the table once. And then from the table we get the values as summation dx is equal to minus 4 and summation dx square is equal to 160, summation dy is equal to 3 and summation dy square is equal to 195, and the last value summation dx into dy is equal to 76. So from Karl Pearson's coefficient of correlation using step deviation method, the formula is r is equal to n into summation dx into dy minus summation dx into summation dy by root of n into summation dx square minus summation dx whole square into root of n into summation dy square minus summation dy whole square. Make sure that the formula is similar to that of this, and then substituting the values as n is 10 and summation dx into dy is 76. So I am substitute this, and summation dx into dy, summation dx into summation dy is these two values, product of these two values is minus 12, and minus into minus plus 12 by root of 10 into, as n is 10 into summation dx square, summation dx square is equal to 160 minus summation dx whole square, summation dx is this minus 4 whole square is equal to 16, here minus minus, and similarly here root of and 10 into summation dy square, summation dy square is equal to 195 minus summation dy whole square, summation dy is 3 and its square is 9, and and after calculating the value we get it as 0.4402 or 0.42 approximate value. Hope you understand the topic. See the formula once, and it is the question. Hope you understand the topic. Thank you.